In this video, I'd be talking about code synchronization in threads in Java. Consider this example, right, in which you have a class account with these data members and and methods, and you have account danger implements runnable, in which you implement the run method, and you create a thread and you give it R, um, right, so that one would execute this run method, and two would also execute the same run method on the same instance R, right? And then you start both the threads. So when you start both the threads, the same run is executed on the instance R, because that is what you have passed to both the threads. So this is my main method. This is my main method in the main thread, and after executing these two statements, it would spawn two threads with run at the bottom of the stacks for both the threads, which are invoked on the same instance R, right? So my worker, the worker threads are 1 and 2, and the target or the job here is R. So both the threads are working on the same job. Now, right. So say for example, 1 gets in and 2 gets into, and then you make a withdrawal. Now, say for example, if you only had $10 in your as your bank balance, 1 comes in and it executes this method, right, and then it jumps in, and then it says, well, it cannot get balance, which is $10 is greater than or equal to the amount 1 has to withdraw, which is 10, which is true. So it goes in and sleeps for a while. Now B comes in and then it wants to withdraw $10, but you only had $10, which A has already withdrawn. Now B checks the same condition and this evaluates to true, because A has just made a condition check but hasn't actually withdrawn. But before that, B came in and made a condition check just like A did, and the condition evaluated to true, and then B would sleep for 500 milliseconds. Now A would come here and withdraw the $10, and B would making the balance 0. Now B would come in and withdraw the same $10, and making the balance minus $10. So there's a problem there, right? So what you would want to do is you would want to provide some sort of synchronization, right? So when thread 1 is executing the make withdrawal, thread 2 should wait until thread 1 is done and proceed with the condition check, in which case it's going to fail and it doesn't show the balance to be minus $10. Now, how do you actually protect data members in such kind of commonly shared data member scenario? So one thing that you have to do is to make them private, so you can avoid accidental access from another thread. So for example, I cannot if I would have made balance public, I could have accidentally modified it from my main method. So in order to avoid such kind of accidental or inadvertent modifications, you need to make them private. Now the most important solution is to make the methods that access data members run atomically. And how would you do that? You could do that by adding the synchronized keyword, right? Now, okay, so let's take a look at this. T1 uh, has T1. You're submitting job R1 to T1 and R2 to T2. And if you were to do so, what's actually happening is, these are the data members within thread class. So the job would be pointing to R1, and this one is actually R1 here, right? Now T2 would be pointing to T2's job would be pointing to R1, right? So when you do this, when you do class my runnable implements runnable, and you have a common member, right? So when you do t1 dot start, it would invoke run method on R1, because if you look at the implementation of start, that's what it does: create a stack and invoke run on R1, because, well, essentially invoke run on job, but job contains R1, so it invokes R1.run, and T2 invokes R1.run, right? Now if T1 executes the modify member, so this is the method which would be modifying the data member, right? So when run is invoked on R1 and run is invoked on R1 in two different threads. Now this is the method which is called within the run method. So this method would be modifying member M. Now if T1 executes, so in order to make this method atomically accessible, you add this keyword synchronized. In Once you do that, if T1 executes modify member, which is a synchronized method, um, uh, before T2, then T1 acquires R1's lock and goes to execute the modify member, which is the method. Now T2 should wait for R1's lock. Now, right? Now R1's lock is released when T1 is done with modify member. So if T1 is the thread which enters modify member, now because it's a synchronized method, T1 should acquire the lock of R1 before entering this method, and it holds on to the lock of R1 until it is done with the method. Now if T2 were try and execute the same method while T1 was holding the lock, then T2 is sent to the lock pool of R1, where it would wait until T1 is done and the lock is released. If you don't use synchronized methods properly, you might end up with deadlocks. So what's really important here is to know that if thread T2 were to be tied up to a different job, right, a different object R2, then T2 wouldn't be blocked. If T1 was T1 had a hold of this method, because T1 has the lock of R1, and in this case T2 has the lock of R2, right? So T1 and T2 are holding on locks of different instances, or different jobs. So they don't wait for each other because they're not operating on the same instance. So when talking about synchronization, threads operate on the same object, right? That's when one thread would lock out another one, right? Now if for example T1 has the lock of R1, and it tries to access and you call well right, so T1 um, it started, so which would invoke run on R1, and then the run method would invoke synchronized method, which is synchronized. Now T1 would obtain the lock of R1, and it would call another synchronized method. Now because on R1, now because T1 already has the lock of R1, it would call this method without acquiring a new lock, because it already has the lock of R1. So a thread can acquire more than one lock. So in this case, T1, before executing this method, T1 acquires the lock of R1, and if R1 were to invoke, or within this method, if you were to invoke synchronized method 1 on R2, which is a different instance, then T1 gets the lock of R2 as well. Now, synchronized methods hurt concurrency. So if you have a method which doesn't need synchronization for all its code, but only a specific part of it, then you could use synchronized blocks. Um, right. Right. So within this method, you only want this part of the code to be atomically accessed by different threads. So you would say synchronize of this or any object, because the thread needs to lock off an object before proceeding into the synchronized block. Now, right, in case of static instances, or sorry, static methods, um, you would have right. So say for example your run is invoking a static method, then you would have you can only access static members within the static method. So the only necessity here is to protect the static data members, but not the instance data members. Um, uh, so so you would so when you have something like this, when you have a static synchronized block, um, the thread gets a lock of the class instance of my class, right, or the class which implements this method. Now, alternatively, in order to provide synchronized blocks within synchronize or within static methods, you could do synchronize my class, which is a class literal, which finds the instance of class that represents class my class. So you could have both static and non-static methods synchronized. So that is, you could have the synchronized keyword on both static and non-static methods. In case of non-static methods, the thread acquires the lock of the instance which invokes the method. In case of static methods, the thread would acquire the lock of class instance of that particular class which defines the static method. Okay, these are pretty simple rules out here. Just read through them. They're straightforward.